This video is a sample problem in vector addition. A vector is a quantity that has a magnitude and has direction, and vector techniques are useful in solving physics problems as well as other problems, but in this particular case we just want to do a simple calculation of adding two vectors together and subtracting a vector, a plus b minus c, and the bold face here indicates it's a vector. So A is a magnitude of 8 centimeters, an angle of 40 degrees, measured from the positive x-axis. I'll use x and y axes here. The x-axis is typically drawn horizontal, the y-axis at a 90-degree angle to the x-axis, and our angles are measured counterclockwise from the x-axis, from the positive x-axis. Vector B, 15 centimeters, angle of 60 degrees, and vector C, 20 centimeters, angle of 130 degrees, so it puts it into the second quadrant. So first I'll use a graphical method that gives a rough idea where the answer will lie, and then an analytical method that gives the more or less exact answer, a little rounding of numbers, but a mathematical method. So here's the graphical method. The x-axis is our reference line for the angles. I'm starting by drawing vector A, starting at the origin, and I just estimated here 40-degree angle, and I estimated 8 centimeters. I didn't try to make an accurate graphical drawing, just a rough approximation. Vector B is longer than vector A, and it's also steeper, angle of 60 degrees. 60 degrees from where? Well, 60 degrees from a new x-axis that's parallel to this primary x-axis down here. So 60 degrees up from there. And then vector C itself extends out up and to the left, an angle of 130 degrees. Again, just imagine a new x-axis that goes off horizontally from the tip of the B vector. And 130 degrees would put it out here. Minus means you reverse the direction. So minus C, a vector that's 20 centimeters long and would lie here actually 50 degrees below this new x-axis up here. So what we expect is a vector A plus B minus C. We expect a vector that doesn't have a very big angle. It's lying fairly close to the x-axis, and it's longer than any of these three separate vectors. So let's see what the analytical solution gives us. To do the analytical solution, we have to work with components of vectors. So the result vector has an x component. That's simply found by adding the x components of A and B and then subtracting the x component of C. Again, remember we have this minus sign to deal with in this calculation. For the y component, similarly add the two y components for B, subtract the y component for C. The positive x-axis is at 0 degrees, and counterclockwise, if I start from x and go in this sense, this rotation, counterclockwise, that's a positive angle. To find the components, you need to be familiar with right triangles. So the magnitude of vector A is the hypotenuse here. And if I take A times cosine of theta, that gives me the adjacent side, gives me the A sub x. And magnitude of A, the hypotenuse, multiplied by the sine of theta, the sine of theta multiplication produces the opposite side in the triangle. It gives me A sub y. As you're doing this, double check that your calculator is in degree mode. I'm not giving you radians for the angle here. I'm giving you degrees, so should be in degree mode. A quick check. Use your calculator and evaluate sine of 30 degrees. You should come up with exactly 0.5. Again, this analytic method, adding the components. As you do this, when you get the resultant for the x component, I can only add x components of A, B, and C, combined x components. There's a negative here. I cannot put in a sub x plus b sub y minus c sub x. So need x components all along here. And similar for the y component of the result, I must only use y components in the calculation. After we're done with this r sub x and r sub y calculation, we'll reconstruct the vector. We'll get the magnitude of the resultant vector by taking the square root of the squares of rx and ry. And you might recognize this as really we're getting involved with Pythagorean theorem work here. And if I go back to this slide, this a squared and equals the square of this side plus the square of this side. Well, how do I find the angle? I use the inverse tangent function to find the angle. Tangent of theta would be a sub y divided by a sub x, or if this was an r sub y divided by r sub x. So tangent of theta is the ratio of those two sides. To find the angle, I use the inverse tangent function. And again, if your calculator is set to degrees, you'll get an answer in degrees. If your calculator is not set to degrees, it's probably in radians, and you'll get a strange looking number to you. Then think about the quadrant. This inverse tangent function does not return all possible angles from 0 to 360 degrees. It's restricted. So you have to think about what quadrant you're in and then possibly adjust the angle your calculator tells you to give the correct result. If Rx and Ry are both positive numbers, then we're in the first quadrant, and the angle will come back in between 0 and 90 degrees. If R sub x is negative and Ry is positive, then we're in the second quadrant, and the angle should be coming back between 90 and 180. That won't happen on your calculator. You're going to have to manually adjust that. So be aware of what quadrant you're in. Make a little sketch with Rx and Ry, and be ready to adjust the number your calculator gives you using your knowledge of right triangles and trigonometry. Okay, well, let's find these components. And I'm not going to put in all of the work here that's done for this. I've done it just for the A vector. But to find a sub x, I take the magnitude of A, 8, times the cosine of 40 degrees. I've rounded a little bit here, 6.128. And the a sub y component is 5.142. In a similar calculation, the bx is going to be 15 times cosine of 60 degrees, and b sub y is going to be 15 multiplied by sine of 60 degrees. C sub x, you have to be a little careful here and pay attention to your plus and minus signs. Your calculator will automatically give you the correct plus or minus value. But C sub x is 20 centimeters times the cosine of 130 degrees. That will automatically come up as a negative, as it should, to be back into the second quadrant. And the sine calculation, 20 times the sine of 130 degrees, this will automatically come up as a positive, as it should, 15.321. Well, how do we find r sub x? Our calculation is a sub x plus b sub x minus c sub x. Pay attention to your signs here. The minus sign that's right in after the 7.5, that minus sign comes from the minus sign in our desired calculation. The minus sign in front of the 12, that's being generated because c sub x is a negative number. And when you have two negatives, you get a positive. So we get 26.484 for the arithmetic here. And r sub y, now the 15 is a positive number for c sub y. So it ends up pulling our result back closer to 0, and r sub y is only 2.811. Now reconstruct the vector by doing the squares of the two components of r. Square those, add them up, take a square root. You get 26.6 centimeters. Notice this is longer than any of the three A, B, and C magnitudes, as we expected from our drawing. And then what's the angle? Well, inverse tangent gives us the calculation you need to do. First do 2.811 divided by 26.484, get that result, and then apply the inverse tangent function on your calculator, and you get a little over 6 degrees, as we expected, somewhat near the x-axis. We're in quadrant number 1. Well, for more of these introductory physics videos and some short lectures as well, you can see a list of the videos at my website, gpclements.com. The list has an annotated form. It gives the title of the video. It gives a link to the YouTube video directly. It gives a number of minutes the video lasts and a little description of the video. All the content, all my videos are free. You're not allowed to resell them, but all free. You don't register at my website. You don't give me your name. You don't give me your email address, anything. And my website does not put cookies on your computer. So keep working physics problems. Ask your instructor if you have questions.